The first part of 2.4 is types of discontinuities. So there are 3 different types, and we're going to talk about the 3. So go ahead and glue that down. Looks like some of y'all got some bad. Sorry about that. You know what happened. All right. Anybody else get a bad one? Sorry. So a discontinuity is a place where the graph is not continuous. That's what it means. And there's 3 different types. And you do need to memorize these 3. The first one is a removable. I think the easiest way to recognize a removable is a hole in the graph. It looks like a hole is in the graph. So if you imagine that this is you walking on a ramp, you have to step over the hole. But both sides of the ramp are connected to the hole. But it's literally just a hole in the graph. A jump is disconnected. So you actually have 2 different graphs. So if you think of it as 2 sidewalks that don't meet up. So in this one, see how both sides touch the pothole. But over here, if I was walking on a ramp, when I get to the top of the ramp, I actually have to jump to get to the next ramp. It's not connected. And the last one is an infinite. An infinite occurs when you divide by 0. Because remember, we talked about the 2 red lights. When you divide by 0, you get an error. It causes an asymptote. So what happens is you can't go through it, so the graph just has to either make a decision. Is it going to go up the wall or down the wall? But if you think of this as an asymptote, on both sides of that wall, the graph should approach either positive or negative infinity. So this one just happens to be one where on one side is going up and the other side is going down. But you can have a discontinuity, an infinite discontinuity, where both sides are going up or both sides are going down. So on your test next week, you will be given a graph and you will need to name the type of discontinuity and tell me where it's at. So let's practice. Go ahead and glue down the second graph. Okay. So this graph has a lot of different discontinuities. Let's start off very, very far left. So right here, at x equals -7, that's a removable discontinuity because there's a hole in the graph. Now, if this point was like a line, then what do you think that would change this to? Instead of a removable, what do you think we would call that? A jump. But we don't have that. All we have is a point. So at x equals -7, it's removable. And then as we're traveling along, notice that again, here at -3, we have another hole in the graph. So we have another removable at -3. And then at +2, what do you think that is? What are we going to call that discontinuity? It's not connected, so it's a jump. Good job. And then here at x equals 4, notice how the graph is approaching positive and negative infinity. So at x equals 4, that would be an infinite. Any questions? So on the test next week, you're going to have a graph. It won't be this big. And they'll have 2 different discontinuities, and you'll just have to tell me if it's a removable, a jump, or infinite. That's it. All right. Now let's do the second piece, which is graphing something. So we're going to do number 1 together. This is my 3rd time doing this, and it was kind of, I'm going to model for you how to approach this question on the quiz. So I'm going to give you a couple minutes to copy this down. You don't need a whole lot of space. We're just going to make a little graph. Okay. Boy, I tell you. So we have 2 different discontinuities for the first one. So So looking at number one is telling us that at -3, so I'm just going to highlight where it should occur. So along this line of -3, I need to have a hole somewhere on that line. It doesn't matter where I put it. You can pick any y value. So I'm just going to go here. All right, so I'm going to draw. I usually stick with straight lines because, you know, that's easy. I'm just going to go a straight line. And this straight line is going to travel until it gets to 0. Now, when it gets to 0, though, it's going to encounter another problem. When it hits 0, it's going to stop. And then somewhere along this green wall, I need to jump either up or down and create a brand new function that's traveling to the right. So when I do my jump, I'm going to jump down. I'm going to put an open circle. It could be open or closed. And again, I'm just going to keep it simple and just make it go that way. That's like a really basic graph. And notice I said answers will vary because there's a lot of different ways that you can draw it. Like I didn't have to make this a 2 lines. I could have made them parabolas. I could have made them absolute values. I just try to keep it simple and do the most basic, which is a square, which is 2 straight lines. Yes.
Does it matter if the holes are open?
Thank you for asking that question. Okay, when you have a jump, you can have either 2 open circles or 1 open circle. But what you cannot have is 2 closed circles, and let me explain why. If I have 2 closed circles, that means in this scenario, I have a point at 0,7, and I would have a point at 0,1, which, going back to the quiz we took yesterday, we know that in order for it to be a function, x cannot repeat. So one of these points needs to be open, and it doesn't matter which one. You can keep them both open if you want to, but what you cannot have is 2 closed circles. Okay, I knew something went away. It was my little wall. All right, go ahead and copy down this next one. We're going to work through that one together. Now we're going to have 3 on one graph. So now we have 3 different ones that we need to include. So I'm going to draw in my 3 walls. So at somewhere around x equals -2, I need to have something that's going to happen here. It's going to be an infinite. Then at +1, I'm going to put a little hole. And then at +5, I have something. So what I want you to do is go one at a time. What needs to happen in order for for an infinite discontinuity to occur. What does that mean when I say there's an infinite discontinuity? The graph is doing what? Either it's going up to positive infinity or it's going down to negative infinity. So what I'm going to do is I'm going to draw a graph. And I think I'm going to make my graph go up on both sides. So I'm going to draw a graph that kind of comes up. It gets to the wall and it rolls up the wall just like that. On the other side, it's going to do the same. Get to the wall, then it's going to come to this pink wall, and it has to stop. Okay, so we have a removable, and the removable is going to happen at x equals 1. So when I get to this point, I'm going to put a closed circle here. No, sorry, not a closed circle. An open circle has to happen right there at the 1. It's a removable. Removable, both sides will touch it. So then it's going to keep going until it hits the next wall. When it hits the next wall, we have a closed circle or an open circle, and it needs to jump up or down and then go to the right. All right, y'all. So that's it. So let's do a couple graphs. We're going to go back, just do a couple of them. Just remind you how to graph a couple of these functions. And then kind of go from there. So looking at this equation, does anyone recognize what kind of graph this is going to be? Because you do have to know, you have to have a little bit of memory about what the different graphs look like. And I will try to put it up, but I think I heard somebody say it. A parabola. I heard it, I don't know who said it. It's a parabola because it's a quadratic. So this one is going to look something like this, which is symmetrical. Now we don't have any red lights, which tells me that my domain is all real numbers. So I'm going to make my table. And I can use any number for x. So here's my recommendation when you're graphing a parabola. Who remembers AH and K from Algebra 2? So this is H and this is K. And what we know about H and K is that's the middle. We always flip this sign. So this is positive 1. It's going to become a negative 1. So negative 1, negative 4, we're going to call that, that's our vertex, which is the middle of the graph. Okay. So that's the middle of the graph. And what we know is that it's symmetrical. So looking at the negative 1. Okay, so this is negative 1. what are my two numbers on the left side and right side of negative 1? So if I go to the right, it would be a 0 and a 1, right? And if you go to the left, it's negative 2, negative 3. So what I want you to do is we're going to just fill it in. We're going to put a 0, a 1, a negative 2, and a negative 3. The good thing about this, though, is that it's symmetrical. So whatever I get for 1, I should get the same thing for negative 3. And whatever you get for 0, you should get the same thing for negative 2. So take a moment and let's figure out what we get for our other values. So for the first one, you're going to have 2 times, and then you're going to put a 1 plus 1 squared minus 4. See what you get. Then do the same thing with 0. 2. Now you're going to substitute in a 0. So see what you get for that. So go ahead and substitute it in and see what you get. History. Did you have your hand up? Or you have the answers? I know y'all tired. This week's been a rough week. Even though it's only 4 days, I am really tired. My lupus is activated. I'm stressed. Okay, now I got a phone call. This is Miss Brain. No, I don't have any barcodes. Okay. Okay, so we got 1 plus 1, which is 2. 2 squared is 4. 2 times 4 is 8. And 8 minus 4 is 4. Who got 4? Yay. So I know I'm going to get the same thing for negative 3. I'm just going to put it there. And if you don't believe me, you can test it out. But I'm just trying to help y'all save a little bit of time. You will get the same thing. Now let's do the same thing with that 0. Okay, 1 squared is 1. 2 times 1 is 2. 2 minus 4 is negative 2. Who got negative 2 for these two? All right, let's graph it out. So we got a point at 1, 4. I have a point at 0, negative 2. A point at negative 1, negative 4. Then I'm going to make my little U-turn and come back up. And this is what your graph should look like. Domain is all real numbers. What's our lowest y value? How low do we go for y? Negative 4 to infinity. All right, we'll do one more graph and then we'll end for today. Now, the bad news is that the next graph we're going to do is called an absolute value, and your calculators don't have an absolute value, so you're going to have to do a little math, like using your brain. So let's go ahead and do this last one. This is an absolute value. Absolute value functions looks like the letter V. So it looks really close to a parabola, except the vertex is a point. That's what it looks like. Absolute value is not a restriction in your domain. It's not a red light, so our domain is still going to be all real numbers. And we're going to stick with that domain unless we have a square root, which we'll have on Monday, or an x in our denominator. And we really won't talk about x's in our denominator until we get to chapter 4. So the good thing about this is I want you to set it up the exact same way. We're going to put our vertex in the middle. So where do you think my vertex is going to be? Is it positive 3, negative 5, or negative 3, negative 5? Remember, you always flip the sign. Write that in your notes. If it's in parentheses, you flip the sign. If it's under a square root, we have to flip the sign. If it's inside absolute values, we flip the sign. So that negative 3 becomes a positive 3. So 3, negative 5 is my vertex. And again, going back, I just want you to pick the numbers right next to 3. So here's my 3. Just go 2, 1, and 4, 5. That's it. Stay close to 3. No need to go far away from 3. Now you could, because your domain is all real numbers, but why? Let's just stay right close to the 3. So we're going to put in 2 and 1, and then 4 and 5. These are going to be the same. And these are going to be the same. So we don't have to do it. We only need to do it 2 times. So let's go through it together. So we have 2 times the absolute value. Let's put our 1 in. What is 1 minus 3? All right, so I have 2 times the absolute value of negative 2 minus 5. Okay. Who remembers what the absolute value of negative 2 is? 2. Because absolute value is just saying how many hops to 0. So if I'm at negative 2, it's still 2 hops to 0. Even though I'm coming from the other side, it's still just 2 hops to get to 0. So my absolute value is 2. So this is going to become a positive 2. Now I can drop the absolute value and have parentheses. 2 times 2 is 4, and 4 minus 5 is negative 1. I'm going to put that here. And I'm also going to put that for 5 because I'm going to get the same answer if I did it with a positive 5. All right. Now let's do one more. Let's do 2. 2 times. Okay, now I'm going to put in a 2. And then we'll be done, y'all. I'll show you your test. I know it's been rough. So first we're going to do 2 minus 3. 2 minus 3 is negative 1. What's the absolute value of negative 1? Positive 1. 2 minus 5 would be a negative 3. All right, let's go ahead and graph these 4 points. So I have a point at 1, negative 1. 1, negative 1, 2, negative 3, and then make sure it looks like a pointed. It should be pointed. That's what your graph looks like. With a range of negative 5 to infinity.